Lesson 1-4, Functions and Functional Notation. A relation is a rule that relates two quantities. So here's two quantities. The first group I could call x, and the second group I could call y. And the arrows show the relationship. 1 in the x goes to 7 in the y. 2 in the x goes to 7 in the y, and so on. A function is a special relation. A function of f from set A, so let's call this first group maybe A now, and the second group we'll call B. So from set A to set B is a relation that assigns each element in x to exactly one element, or one element x in A to one element in set B. So the 1 goes just to the 7, the 2 goes just to the 7, the 3 goes just to the 8. So this is a function because each of the things in A goes to exactly one thing in B. This is the inputs or the domain. This is the output or the range. So, is this table representing a function? Well, I don't know. I have to look at each x. Is it paired with just one y? Well, the -2 just goes to the -8, -1 just goes to -1, 0 just goes to 0, 1 just goes to 1, 2 just goes to 8. So yes, each x goes to only one y. However, if I added another point that said 0, 5, then it would be no, because 0 would go to two things. How about this equation? Does it represent a function? Well, let's solve it for y. So subtract the x squared. And then we have to think, if I fill in a number for x, how many numbers for y will I get? Just one. So this is a function. Each x gives one y. How about this one? Well, again, let's solve it for y. Well, remember, when you're solving an equation and you take a square root, you have to have a plus and minus. So now, if I fill in a number for x, will I get just one number for y? No, because each x gives two y's, because we have the plus and the minus. So you put in an x value, you'll get a positive and a negative y value. So it's not a function. Math likes using functions, and so we have special functional notation. This f of x is the functional notation. The f is the name of the function. That way we can list several functions and give them different names so we know which one we're talking about. The thing in the parentheses by the name, in this case the x, is the value of the variable. And then that equals the actual function. So let's evaluate. So this function's name is f, the variable is y, and we have our function. So what's f of 4? So notice the y was replaced by a 4. So we will replace the y with 4. Square root of 4 is 2. 3 minus 2 is 1. So f of 4 is 1, which means function f, when I plug in a 4, I get a 1. Let's try f of 4x squared. So that replaces the y. The 4x squared replaces the y. So where the y is, I'm going to put 4x squared. Square root of 4 is 2, and the square root of x squared is x. And then those are not like terms, so I can't simplify it. So f of 4x squared is 3 minus 2x. There's an interesting type of function called a piecewise function. It's made up of several pieces with specific domains, like the one that you see there. So when you evaluate them, you have to look at the value of x. -1. -1 is less than 0, so it fits in that domain. So we're going to use the top equation because the x value fits in the domain. So let me just plug it in. And we'll hit -2 plus 1, which is -1. However, to find f of 2, 2 is bigger than 0. So we're going to use the bottom piece. We'll plug in the 2 to the bottom one. You get 6. So you just had to compare your x value with the specific domains here and see which piece you get to use, the top or the bottom. Speaking of domains, the domain of a function, usually we do an implied domain, which is all the real numbers for which it is defined. And we're going to learn how to write it in interval notation. Square brackets means equal to. Parentheses means not equal to. So if I have parenthesis 2, 7, bracket, that's the same thing as the x's that we start at the 2. We don't include it. There's no equal there. And we stop at the 7. But since it has the square bracket, we have the equal to sign. That's what that square bracket means. It means we have the equal to. So it just means x is between the 2 and the 7, and we get to include the 7. So what is the domain here? Well, when we divide, you can't divide by 0. So you probably just want to say x doesn't equal 0. Or t, sorry. T doesn't equal 0. But if I do interval notation, what's the smallest that it could be? Well, it could be -infinity. And it could be everything up through 0, but not including the 0. And then it could be everything above the 0. So starting at 0, going through infinity. And we're going to put a little u, a union symbol, to combine those. So it's everything less than 0 and everything greater than 0, which means we're not including 0. How about this one? Well, to be real numbers, the stuff in the square root has to be greater than or equal to 0, because square root of 0 is 0, so 0 works. So we'll solve for x, so we'll add 8, divide by 5. So x is greater than or equal to 8/5. How do we write that as interval notation, though? Well, the smallest it could be is 8/5. It could be equal to 8/5, so we have the square bracket. And then it's everything bigger than that, so through infinity. You can never equal infinity, though, so that's just a parenthesis. Now let's have a little introduction to calculus with the difference quotient. It's called different quotient because they're subtracting and dividing. And you can see it's in functional notation. So we just need to write out our two functions, fill them in, and simplify. So here's our function. The first thing we need is f of x plus h. So f of x plus h, the variable becomes x plus h. So where the x is, we're going to put x plus h. So that is f of x plus h. All right, so our difference quotient is f of x plus h, which we said was 2x plus h plus 1. And then it's minus f of x. Well, f of x is 2x plus 1. So this is the f of x plus h minus f of x. And then it's all divided by h. So we simplify, so maybe we could distribute 2x plus 2h plus 1. Then 2x minus 2x goes away. And 1 minus 1 goes away, so the top is just 2h. And then the h's cancel, so it's just 2. It won't always simplify. Sometimes there will be h's left.